In our last video, we decoded the professional benchmarks that measure AI progress. Today, we're diving deeper by introducing 3 benchmarks that have become crucial for understanding the real limits of today's models. We'll be looking at SimpleBench, the new Kaggle Game Arena, and what is arguably the purest test of artificial general intelligence ever created, ARC-AGI. These benchmarks are important because they help explain a paradox. On one hand, language models are achieving superhuman performance in complex abstract domains, but as these new tests show, they can simultaneously fail at tasks a child would find simple. This episode is about why.
The core issue is that models often achieve high scores not through genuine understanding, but by learning clever statistical shortcuts. They are masters of imitation. This makes them vulnerable to adversarial examples, slight changes in a problem that break their learned patterns and cause their logic to shatter. When a model is pushed outside its comfort zone of familiar patterns, it doesn't know that it doesn't know. Instead of admitting uncertainty, it can confidently generate plausible-sounding but completely incorrect information. This is what we call hallucination. It's a system designed to find the next most likely word, not the next most likely truth. This brings us to our first benchmark, SimpleBench. It's designed specifically to create adversarial examples that test for abstraction. The questions use language tricks and conceptual math to invalidate the statistical shortcuts that models rely on. A human can easily see through the noise, but a language model often fails because it processes the syntax perfectly but fails to grasp the underlying causal logic. The second benchmark is the Kaggle Game Arena, a powerful platform from Google that moves evaluation into a live competitive environment where AI agents play strategy games like chess or Go against each other. This is a massive leap forward for testing strategic reasoning. However, as the research paper Impartial Games, a Challenge for Reinforcement Learning reveals, even this advanced setup can hide a deep flaw. The paper shows that while AI can master complex games like chess, it fails spectacularly at impartial games like NIM, which rely on understanding an abstract mathematical principle. The AI hits a representational bottleneck. It can memorize patterns but struggles to learn the underlying abstract rule. But if you want to see the purest distillation of this problem, you have to look at our third benchmark, the Abstraction in Reasoning Corpus, or ARC, hosted by the ARC Prize. This isn't a test of knowledge, it's a test of intelligence itself. Here's how it works. Each ARC problem is a visual reasoning puzzle. You are shown 2 or 3 training pairs. Each pair consists of an input grid of colored squares and a corresponding output grid. These examples demonstrate a single hidden rule or concept. Your task is to look at a final, unseen input grid and generate the correct output grid by applying that same rule. What makes ARC so difficult for AI is that it is designed to be immune to the shortcuts modern models rely on. No language. The problems are purely visual. The model can't use its vast knowledge of text to find clues. Minimal data. With only 2 or 3 examples, the model cannot rely on statistical pattern matching. It must generalize from almost no data. Novelty. Every task's core concept is unique. Memorization is useless. To succeed, you must form a novel abstraction on the spot. It's a direct test of what psychologists call fluid intelligence, the ability to think logically and solve new problems independent of acquired knowledge. Which brings us to today, August 12, 2025. About 10 days ago, OpenAI announced GPT5. The hype is immense, with claims of unprecedented reasoning and capability. But the new results on the ARC-AGI 2 leaderboard tell a more sober story. The brand new state-of-the-art GPT5 scored just 9.9%. For context, the average human score on this benchmark is nearly 100%. This is the perfect illustration of our theme today. A model that can likely write a flawless PhD-level thesis on quantum physics cannot solve simple visual puzzles that are intuitive to a human. So, are language models flawed? Yes. Are they useless? Absolutely not. Their capabilities are transformative. These benchmarks don't invalidate that progress. They illuminate the path forward. The recent introduction of the Game Arena by Google is a crucial and positive movement. It acknowledges the limitations of static tests and pushes the entire field towards more dynamic, robust forms of evaluation. But we need more of this innovation. The future of benchmarking shouldn't just be about comparing AI to humans in isolation. To truly understand these systems, we need a more thorough, multifaceted approach with creative benchmarks that measure AI versus AI to test for raw strategic and competitive capabilities, human versus AI to clearly delineate their respective strengths and weaknesses, and perhaps most importantly, human plus AI versus human to measure the collaborative potential. This brings us back to Moravec's paradox, the strange observation that what is easy for us, like common sense and adaptation, is hard for AI, while what is hard for us, like massive calculation, is easy for them.
The goal, then, isn't just to build a machine that can beat us, but one that complements our intelligence, creating a partnership that is greater than the sum of its parts.
Thanks for watching this. If you like it, subscribe to our channel. Madrasa is a new way to learn technology.